Hello, welcome. Let's try to solve another Leetcode problem, 30 to 75 case nearest obstacle queries. So let me first explain this example. So currently we are having this 2D plane. So it is the x and y coordinates. So what is this meaning? So we are having such kind of queries, and each query going to be x and y. So for each of the query, so for example query I, so first of all it is 1 and 2. So we're going to build an obstacle at coordinates x and y in the plane. It is guaranteed that there's no obstacle at this coordinates when this query is made. So what's the meaning? So from the beginning there's nothing, and then we're going to have the first query 1 to 2. So where is 1 to 2? So this is 1 and this is 2. Yeah. So it means here we're going to have a dot. So this is going to be the first query, and we're going to have a value of absolute of x plus absolute of y. It means we're going to have a value of 3. Now we're going to continue to have the second query. So I will not make the drawing, but the idea is that for the second query we're going to have a 7. Yeah. And we are also giving this integer k. So k means the case nearest obstacles after query I. So what is this meaning? So we're going to return an integer result where result I denotes the case nearest obstacle after query I, or result I equals to -1 if there are less than k obstacles. So what is the meaning? So the case nearest obstacle, it means the case nearest obstacle from the origin. We have to understand what is this origin. So after each query, you need to find the distance of the case nearest obstacle from the origin. So what is the origin? What is the meaning of the origin? Definitely it didn't tell us. Yeah, but from the examples we may guess the origin may be this. This is the origin. It may be 0 and 0. This is going to be the origin. Yeah. Yeah, because according to the question, it didn't tell us what is the origin. It just tells us there is a origin. Yeah. Yeah, let's just read it. There is an infinite 2D plane, and we are giving a positive integer k. We are also giving 2D array queries, which contains the following queries. So queries x, y, we're going to build the obstacles at coordinates x and y in the plane. It is guaranteed that there's no obstacle at this coordinates when this query is made. Yeah, so before we made this query, there's no obstacle. So after each query, we will find the distance of the case nearest obstacle from the origin. Yeah. So according to the question, the distance, so for example, the output here, we're going to have a 7. So maybe the distance is from this query, x plus y. So, yeah, so it is set actually from here. So the distance of the obstacle at coordinates x, y from the origin is given absolute x plus absolute y. It means the distance from here to 0. Yeah, but it's going to be the Manhattan distance. So it's going to be absolute of x plus absolute of y. So this means we can solve this problem by using maybe priority queue. So the idea is that we're going to use a min heap. Yeah, we're going to use the min heap because we're going to find the case nearest obstacle, and we can also understand that we're going to find the case smallest number. So this is the first smallest number, and 7 is going to be the second smallest number. Yeah. So from the beginning, it's going to be a -1 because there's only 1 dot. Now we have 2 dots. So the second smallest number is going to be, it's going to be 7. And then we're going to have another number. It's going to be 5. Yeah. So what's going to be the second smallest? It's going to be 5 here. Yeah. And then we're going to put 3. So if we put 3 inside, what's going to be the second smallest? It's going to be 3. It is here. Yeah. So this means we can solve this problem by using the min heap. Yeah. So let's do some preparations. N going to be length of the queries, and let me prepare the result. It's going to be -1 times n, and then let's just prepare a priority queue, or we're going to call it min heap. Yeah. So now let's just check each one of them. So for I, A, B, or let's just use x and y in enumerate the queries. Yeah, so for each of the query, what we're going to do? We're going to put it inside the min heap. So we're going to use the heap push. it's going to be the mean heap, and it's going to be a value of absolute x plus absolute y as yeah, I'm sorry, this is not mean heap. We're going to use the max heap to solve the problem. Yeah, because for the max heap, basically we're going to pop out the largest number. And here for this problem, because we are going to find the case smallest number, so basically we need to pop out the largest number. We're going to keep the smallest number, so we're going to use a max heap. Yeah. Now here we're going to assign a negative value. Yeah, because in Python there's no max heap, so we're going to assign a negative value as the max heap. Now we're going to check the length of the heap. So here going to be the max heap. So if the length of the heap is more than k, so this means basically we need to pop it out. Yeah, so we're going to use heap pop. It's going to be this max heap. Yeah. So after that, we're going to check the length of the max heap. So if the length is equal to k, so basically it means we're going to set the value. So the result I, we're going to set this value. It's going to be the max heap with a value of 0. Yeah. So this is going to be the smallest number, but if we give a negative sign, so this is going to be the case. This is going to be the case smallest number. Yeah. Currently, this one will be the largest number. If we give currently this one going to be the smallest number. If we give a negative sign, it's going to be the largest number, and this largest number going to be the case smallest number. So finally, we're going to return the result. Yeah. Now as you can see, it works. Now let me just loop through the testing case again, just to check what we are doing. Yeah. So the first step is that we're going to have 3, because the length of the heap is only 1. So the result is going to be a negative 1. And then we're going to have a value of 7, and this 7 is going to be the case smallest, the second smallest number. Yeah. As we assign a negative value, this is a negative value, so this means we're going to pop out, we didn't need to pop it out because currently it equals to k only, and we're going to choose the max heap 0, it's going to be this negative 7, and we're going to assign this 7 to result 1. Yeah. Now we're going to put another value, negative 5 inside. So if we put a negative 5 inside, what's going to happen is we're going to pop out the largest number. Currently, we're going to pop out the smallest number. Actually, it's going to be this negative 7. Actually, this 7 is going to be the largest number. Yeah. Now what left behind is minus 3 and minus 5. Yeah. And if this is equal to k, so the result 2 going to equal to the max heap 0. It's going to be negative 5, and then we're going to give a negative sign. It's going to be 5. So this is why the index 2 going to be 5, and similarly for others. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. Now let's analyze the time complexity, and it is n log with k. Because inside the heap, the maximum there are going to be k elements, and n going to be the length of the queries. So it's going to be this number, n log k, and k going to be 10 to the power 5. So basically, it is n log n time. That is why it works. Thank you for watching. See you next time.